Hi, I'm Lee Trager. I'm an FBNIC software engineer at Meta, and today I'm going to be talking about open source tooling for PHY management and testing. So I'm going to just go over what I mean by PHY management today, what vendor tools do today, a little recap of what we discussed at last year's Netdev, and then the proposal I have for F-tool integration. So what am I meaning about PHY management and testing? So the management that I'm talking about is TX coefficients. So modern Ethernet uses pulse amplitude modulation, or PAM, to achieve a high rate of speed. This allows increasing data being sent by defining ranges for different combinations of bits. So you can see in the graphic right here, we're sending one signal through the wire and we're getting 2 bits. And this helps increase our rate of speed. And this is how we're achieving 100 gigabit, 400 gigabit, and even faster in the future rates. Now, these ranges differ based on the mode we're in, either PAM4 or NRZ, but the values are typically static and seldom change. But during hardware interoperability testing, we do need to have these values evaluated, tested, and potentially modified. And so this is kind of how I started on this project. Is our hardware interoperability team came to me and said, hey, NVIDIA and Broadcom both have a way to do this. How do we do it in FBNIC? And I started looking into this and realized there is no community way to do this. So how are we testing if these TX coefficients are valid for us? Well, we're doing PRBS testing, or pseudo-random binary sequence testing, and this sends or receives random binary sequences to the device. And it's used to perform, as I said, data integrity tests on the link. So we actually don't have the link up. We're just sending these random bit streams, validating that we're not getting errors. And we use error counters to determine the link stability. This isn't a self-contained test. We actually run PRBS testing, then look at the error counters separately. Because of this, the user actually determines when to start and stop the testing. It runs indefinitely. It's only when the user says, I've collected enough data, I'm ready to move on, that they stop it, or we have a safety mechanism where if the firmware detects that the host went away, then we automatically stop it. So what are vendors doing? Let's look at a couple of examples. So we have Mellanox here, or NVIDIA, and we can just show using their tool MST-Link, and you can see on the bottom of the screen, it prints some other information, but each lane, it shows 4 values, and these values are the TX coefficients. So we can see here, they're showing, just as I said, 4 of them. It's a comma-separated list. All lanes are using the same thing. Now to set them, you can see up here, there's another comma-separated list that we just passed to it, and that tells it to reconfigure the COM/PHY with those values. For PRBS testing, again, we use their tool where we specify which test we want to run. So we're running the PRBS 31 test here, and to turn it off, again, a separate command to turn it off. Broadcom is very similar, where they're only showing actually 1 lane in this output here. But you can see here, they're showing a few more because with TX coefficients, you can have certain different arguments. So some vendors have more or less. And again, to set it here, they don't use a comma-separated list, but you have to specify each value and what mod type it is. But again, it's very similar to what NVIDIA is doing. You have a list of values, and then you set the list of values. PRBS testing, again, is the same as what NVIDIA is doing, where you specify the test. You can specify the lanes that the test is running on. They do allow setting a duration, so it automatically stops. That's an optional thing. Or you can just manually say, I want to stop at this point right here. So with FBNIC, as I said, I got a request to add support from our internal teams, and there's no open source tooling for this. We do not have our own proprietary tool. We are really trying to work with the community to extend the features, but I had to give them something quickly. So I implemented this in debugfs. I'm very well aware that this would not be accepted upstream, so this is a proof of concept just to show to internal teams we can do this and they can move on while I work with the community here to get an open source standard. But again, it's very, very similar to what other vendors are doing. It's just a list of values. For me, I just have each file has its own value. You can do a short little shell script here to print out all the values. One thing I did that you can see is a little different is typically these values are the same for all lanes. So we have a global section that just allows you to easily modify all lanes with one command, or you can see the individual values. And setting the values, again, it's very simple. You just echo to the file, and then you set. We have a control, because again, you're doing one file at a time. We want to reconfigure the whole conf.i at once. We don't want to do it each time we set an individual value. And again, this is a proof of concept just for our internal teams, and I'm showing here that we are doing the same thing that other vendors are doing. PRBS testing is very similar. We do need the link down, so I show that here that we do take the link down. And then we just specify the tests, whether we want TXPRBS 810 going or not, start and stop. Very similar. So what you can see is that we have 3 different vendors all doing basically the same thing. And last year at NetDev 18, in the driver and hardware API workshop, we discussed this on do we allow different knobs to be implemented, or should we have a community standard? So here's a short recap.
If nothing else, it's not 10 years time. We're probably looking at a year or two, because usually the vendors all tend to release the same kind of features around that time, to where they all kind of roll out with things generally around the same time. Just what we don't want to get is lock in on, okay, whoever's first gets to define what the interface looks like, or just throw an interface in, because then we have all of these interface kludges that end up out there, and then they never roll back. That's right. The thing.
So yeah, as I said, we have 3 vendors, possibly more that I missed, that are all doing the same thing. And I think now is the time to have a discussion how we can have a community standard to implement this feature that works in a way for everybody, that we don't lock anyone in. Meta doesn't want to dictate how these features are done. We want to work with the community. So for TX coefficients, the idea is that we extend ftool. So what are our requirements here, what we need to do? Well, each TX coefficient from Broadcom, Mellanox, and FBNIC can all fit an assigned 8-bit value. We don't need more than that now. When I talk to our hardware engineering teams internally, they do not see needing more than 8 bits per value for the foreseeable future. Manufacturers use between 4 and 7 values per lane, so we do have a little bit of a difference there. And devices use between 2 and 8 lanes. So we do know kind of how much data we need. You know, we need either between, 56 bytes. We could just round it up to even 64 bytes that we want to send between the kernel and ftool. So typically, all lanes do use the same settings, but during testing, they do need to be configured independently. What at least our internal teams will do is they sometimes configure the lanes slightly differently to see how it impacts different, the settings will impact lanes so they can kind of come up to a resolution quickly. And so we also do need to allow the user to change these settings regardless of link state to support PRBS testing. If we only allowed to change these values when the link was up, well, we can't have the link up when PRBS testing is running, so then we couldn't really do the test. So what we're doing in FBNIC right now is you can set these values regardless of link state, but we only reconfigure the conf.i when the conf.i is used, such as the link is up or PRBS is testing. So this is where I want to start opening up to the community here to have an open discussion. We do have already a get and set PHY tunable. So the first question is, do we extend this, or do we feel that we need a new ioctl specifically for this? Should this be able to accept a comma-separated list of values? And how should ftool allow lanes to be configured differently, or independently? I've seen lane mask. I've seen specify lane 1, lane 2, lane 3. So let's start here. Does anyone have any input to any of these things? Yeah.
Okay, so since Jamal likes conflict, I'm going to start with saying the proposition is malformed, right? You're thinking of this as a NIC problem. In fact, it's a PHY problem, right? So if you're using, I'm going to guess dollars to donuts, that you're not building your own PHY. FBNIC has a PHY provider that you bought IP for. And those are the guys you want to have a conversation with, because if you try to solve it per package, it's the wrong answer. Secondly, this question applies to switches as well, and switches don't have 4 values, they have 400 values or 1,000 values, because every lane set has their own parameters. On top of that, you have auto-tuning of TX coefficients, because if you're building a 500 port device, it's not that you're going to have the same values everywhere, you won't. You have to adjust for gain and other issues with routing of the physical lanes. So you will actually have per lane configuration. So you'll have complications there and things like that. So I agree with the general premise that it is a good idea to build into Linux a framework for file management, but it's a file management problem, not a NIC management problem. So it should be seen as a, I mean, if you're talking about how we should address this in the long term, the answer would be to build a file management sublayer, which then converts into ports, because that's the right way to think about it, right? A port is not necessarily a file.
So the way I'm going about it here is I'm starting with the user interface, and that's why I went directly for ftool. The PHY, you're right that it is on the PHY, but the PHY guys aren't involved too much with the open source community. To them, it's build a proprietary tool and move on.
So that's my point, right? I'm saying, like, if you solve it today, what you'll end up with, the way you're looking at it, it's an FB NIC one port instance problem. And I'm saying the problem isn't that. So if we build a solution for that, it'll be a malformed solution because it will not actually broadly apply to everybody else who has the same issue. And so the easiest way to think about this is I'm building a 1,000 port switch. What will that guy do? Because now I have 1,000 times 4 lanes I have to worry about. If you're using PAM4, if you're doing OFPDD or OSFPDD or some other variation, then the lane count becomes different, and so on and so forth. So if you want to build something and you want to propose something that's a standard, then we should build something that addresses that entire community. If instead you say that I've only addressed a NIC that happened to pick PAM4 on 200 gig SerDes, then you will have the same conversation again every year.
So the way at least FBNIC goes, and I'll admit I'm not the PHY expert here, is that we do tie lanes to a specific device.
That's my point. I'm saying that is a you decision, not a general decision.
Well, so just to step in here for a little bit, the lanes are more the PHY portion of it. That's the thing, is we do have an existing interface for PHYs within the kernel. And since Andrew isn't here to answer, I guess I'll step in and try to explain some of that. So one of the things we're going to be looking at most likely for FBNIC is tying all the way down to a PHY driver ultimately. And so like the get set PHY tunable, normally that is something that's at the PHY layer itself. So there's a PHY interface for that. And so the NIC itself will be handing off to the PHY level driver to handle this portion of it. And so if I'm not mistaken, I think that get set PHY tunable is an equal interface to the PHY anyway. And so that is what we're talking about, is actually interfacing with the PHY. It's just going to be a matter of how do we deal with the NVIDIA and Broadcom solutions right now where they don't have that PHY driver that they're working with. Instead, they just have the firmware layer itself, and that's it, and all you have to talk with.
I think, so if I was to try to understand what you said, your solution is it's already complicated, and the way they have solved it is by hiding this complexity inside their firmware. We want to try to take it out, and I'm saying you can't. Like that firmware management is the same whether they're building a switch with 1,000 ports or a NIC with a single port.
Well,
so,
that's the thing is, so this kind of gets back to the whole switch dev. It ends up essentially being your DSA type switch versus these ones where everything's going to be so abstracted and pulled away. And so,
and they have to be, because there are certain places where the lanes are not even straight mapped. You'll have cross mapped devices. You'll have scenarios where you'll have to say port 1 is mapping lanes 1 to 8 and 15, not 1 to 3, 4. So if you, again, if you think of a very narrow use case and say this I can generalize to everybody else, you'll end up in the wrong spot.
well, no, that's the thing though, is there are ways to get around some of that. Like
There
you
are
can't have a
mapping-
sparse lane map with a lane mask. It's not anything where you have to say explicitly that we're locked into, sequential lanes and all that.
I agree. So, and we've done all of those, you know that. So my point is, I'm not saying this as a theoretical conversation. If you want to build that, then we have to build the lane mapping abstraction as well. And that's
Right.
exactly my point. So what people have done, the reason why this doesn't exist as a standard is because everybody says you don't have to worry about that. It's a function of the PHY, it's a function of the board, it's a function of my system design, because then there's coefficients that I have to set based on the system design that I've picked. Because every lane may not be the same even in a large system. So if we want to build all of that, yeah, I'm all for it. But you have to address that entire solution and not just say it's 4 parameters that we are talking about.
Yeah, I don't think we're just saying it's 4 parameters. That's the thing. That's one of the reasons why we're opening it up here. It's what are the interfaces we're going to need for this?
Okay, so then I'm in agreement. Then I'm saying it's a very, very big task, and yes, I would recommend we do it. But it's a big task.
Just maybe to mention another use case which might be a complication for this particular problem. Like on some hardware, you don't have like a simple Mac PHY port thing or a switch port thing. You have, for example, on the Macchiato bin, you can have 2 PHYs muxed to a single RJ45 port. I've also seen a case where you have a Mac, an intermediate PHY, and then an SFP cage, which can have another PHY inside it. So you have 2 PHYs essentially. And this isn't really well represented in the kernel yet. There is ongoing upstreaming efforts by, in particular, Maxime Chevalier to get these PHY topologies represented in the kernel. So that's probably something that you'll need to kind of follow and be aware of if you want to really take into consideration all possible scenarios hardware-wise.
Okay, yeah, I'll take a look at that. Thank you. Any other comments here? Then I will be taking those into consideration as I figure out the upstream approach, but let's move on to PRBS testing with ftool. Hopefully this is a little bit simpler. So here, as I said previously, there's a non-deterministic end of testing. The user starts it and the user decides when to end it. This is how every vendor is doing that today. The exception there is if the firmware notices that the host goes away for any reason, it does end testing automatically, at least on FBNIC. This is how I assume other vendors do it as well, although I haven't explicitly tested that. The link may not be up during testing because we're using the link to do the testing itself. And testing may be run on user-specified lanes. Right now in FBNIC, we're doing this a little automatic, but it should be that the user needs to be able to say, I want these lanes tested or I want all lanes tested.
Lee, there's a question from Zoom.
Okay.
I don't know if we want to bring the Zoom guy, whoever's talking, to speak, or I can just read the question. Mario, what do you prefer to do? So it's from Maxime Chevalier.
Yep, I don't know if you can hear me.
Oh yeah, we can hear you. Okay.
Yep.
Yeah, okay. So what I wanted to say is that there already exist a few drivers for PHYs, especially SerDes PHYs, but they are not located in drivers net PHY, but rather drivers PHY. This is a generic PHY subsystem that handles SerDes lanes. And if you look at this class of drivers, they are for Qualcomm, Mellanox, Marvell. They already seem to have some PRBS, at least at the hardware level support, but no interface to use that. So these drivers are used by the net stack, but they are not really part of the driver's net PHY subsystem, but rather the SerDes subsystem. And usually they are used directly by the NIC driver without going through the PHY subsystem. So the iftool approach could work here, but we have to build a better bridge between the net stack and the generic PHY subsystem, I would say. Like coming up with a generic solution, I think should include these drivers as well. So they are usually for lower speeds, like 1 gig, 5, 10 gigs, maybe a bit more. But I think you should also get in touch with the generic PHY people to see what we can do on that front as well.
Yeah, that's a good point that I wasn't aware of. I mean, I'm not sure. It'd be interesting to see how they're doing PRBS testing with no interface to actually run it. I don't know if you have any knowledge on how they're using that, because that would be kind of interesting to know.
So far, I think they are not using that at all.
Okay. Because, yeah, that's what we were seeing, is that there was no user interface to actually kick this off.
But I think that is part of the point I was making. That is a function of how you've designed the system. Like PRBS is just it's a test pattern generator, right?
Yep.
Like I can decide what my scope is and what my scale is, and often it's in hardware because the Mac SerDes people are aware of what it is that they're trying to drive. So if I'm trying to do like a QSFP DD versus an OSFP design, I may actually have different PRBS scopes, and typically I decide what it is based on the mode that it is in. It's not a user-defined answer because I don't need user input to tell me that, Because all I need to be able to do at the end is, are these lanes working the way I expected them to be? So the point I'm making is, you can solve it, you can do what you're looking for, but I think the generic answer is going to be a big a group hug of people who have very different perspectives on what they are trying to do.
Yeah, and I agree with that. That's why I do want to have a more open discussion, is because you're right. I'm
But
looking at
it's-
it from my perspective, and I'm trying to get other people's perspective to build
And
more
it's
general
not this
solutions.
room that has, it's the SerDes guys that you need to talk to, which is, it's the Marvells, the Broadcoms, the NVIDIAs, the Synopsys, the people who are actually building this stuff.
Okay.
And then the board people, because the combination is what you're trying to hit. It's the people who are also designing the boards.
Yeah.
But if you think of a NIC, it's the easiest, or single port NIC is the easiest answer. And building community consensus around that may actually not be that valuable. But if the moment you say I'm building a more complex system, lots of ports. The Zoom thing is talking to us. Oh, it was talking before. Okay. So if you're trying to build the overall system, it's a good, I mean, don't get me wrong, it's a great thing if you want to take it on, but you'll have to get those guys to come tell you what the lower level interfaces are and build that layer out with all of the functional models that you have to address.
Okay. No, I'm definitely going to take that into account. One other thing I did also want to bring up here is that we do also have to figure out where to put the statistics, where when I was looking on FBNIC, we have specific registers to read for PRBS lock, data count, error count, and BER values. And
Yeah, just one comment to what Srijit said, but on the other hand, you have to start somewhere, and in many cases, those guys from SerDes teams won't know anything about the Linux kernel and even how their stuff is represented there. So you have to meet somewhere, and
That's what I said. I mean, if you're willing to go have those group hugs, then yes, I think. But it'll have to be a pretty large group, and exactly like you said, some people you'll ask the question and the response will be, huh?
Yeah, exactly.
Right.
That's my unfortunate experience, that you'd go and talk and they have absolutely no idea what is it. So.
Yeah, I mean, that is true. I have talked to some PHY people and some hardware engineers, and there is a very much like, implement it, do it this way, we don't care, just make it work for our use case and ignore everybody else. And we're trying to build something that, as you said, big group hug where everyone's happy, and had to start somewhere, so I figured out this community would be a good starting place to kick off that conversation. But as I was saying, for the PRBS testing, I do think that for ftool, there is a cable test, but if you look at the man page as it is today, it is expecting that the cable test runs, finishes, validates, and gives the user output. We could modify it to work in this case, but I kind of lean towards a new ioctl just for this. One question is would we want that ioctl to be very specific to PBR's testing, or more generic where we say this is any test that's just the user determines when it ends, just for future use cases. As well as I was saying with the ftool statistics, do we drop these in FPHY, or do we have a new category specifically for this? So I don't know if anyone has any comments on that. Yes.
Just see, I'm having a problem with just the basic assumption of using ethtool.
So,
because ethtool is a tool for the Netdev.
Yes.
And the Netdev connections to the rest of the hardware are varied and complex, or non-existent. The ethtool connection to this Netdev name, God only knows what that's connected to. And it really doesn't map directly to a specific piece of PHY hardware, except in simple cases. And I think starting with ethtool as your basic assumption is a bad place to start.
Do you have another tool to suggest, or are you suggesting creating a new tool from scratch?
PHY tool. I don't know if that exists. I don't play with them. But I think you need to start from a separate basis, not something that's got a whole culture around it already that doesn't align with the hardware you're looking at.
Okay. I will take that into consideration as well. The main reason I went with that tool is that's just what we tend to use, as you said.
Yeah, well, it's been the tool forever since we had a very simple Ethernet device is the PHY, is the connection to the world. But over the last 30 years, we've grown a little bit more complex.
Yeah, and I do see the need for new tooling. To be honest with you, I was trying to start as simple as possible, and creating a whole new tool in the community, that is a whole other thing in and of itself.
Here's an opportunity for you to define a whole new world.
Okay.
Just as a little note on that, PHY tool does exist, and it's usually used to read and write registers directly from PHY devices. So I don't know if it could be extended into that use case or not, but I usually use it just to read and write registers from PHYs. So yeah.
Okay, that's interesting. We have a way to read and write registers in FBNIC, but we're not using PHY tool right now. Any other questions or comments?
I don't know if you can hear me.
We
I'm
can
on
hear
Zoom. Yeah, so I'm on Zoom. With the PHY tool, yeah, it wouldn't really work because PHY tool is for Ethernet PHYs, which is a different beast than generic PHYs. So the thing with the generic PHY subsystem, the name is really misleading because here we are talking about PHYs for SerDes lanes. So they can be used by NICs, but also by USB, SATA, PCI, and all of these kind of devices that need SerDes lanes, basically. And so I think that here, that work that you are you want to do can really be made more generic without going even through the networking stack. Like you might need information which NIC is connected to which physical PHY, but then the testing in itself is at a lower level than that. There are other consumers than network interfaces for SerDes lanes. So maybe you need to go a bit lower and not even go through ETH2 or any of these higher level when you talk about the PHY level utilities. That's just like one path you can go, but I would get in touch with you later on, see if we can get more people in that discussion as well.
Yeah, that'd be great. Thank you.
So to expand a little bit on what Shannon brought up on just the complexity of the PHYs, and also a little bit about what Srijit was saying in a previous life, and I've been disconnected from this for a little while, so like my connection to PHYs has been unPHYed. But sometimes the vendor who actually builds a NIC doesn't even disclose what PHY they actually have in their IP, right? So if they go and buy a PHY, buy IP integrated into their Mac, they build a board, they ship it, that is totally black boxed off. And getting integration with like PHYlib just doesn't happen. It's all through the driver or firmware on the NIC. So I don't have any solution to this. It's just more of like an FYI. There are some very widespread popular devices that are out there that you might have a challenge. How do you address that? How do you get at that? And that is having a conversation with the Ethernet vendors, but also the PHY vendors to say, how do I get access to like these stats? How do I get access to the signal integrity and all of that on the PHY?
Yeah, and I'm hoping to get more collaboration from other vendors.
Because getting them to disclose what they actually bought to put into the thing is that's a very tricky thing to try to navigate.
I'll just add to PJ's comment. So I think that's a very important thing, right? Like if I'm integrating a PHY, I get to decide in my silicon, how am I going to even expose it to you? Is it an NB-IO bus? Is it a direct map register? That's my call, right? If I'm taking some vendor's PHY and plugging it in, there is no requirement today on me to give you even an interface.
That is partially why I was thinking of making this very abstract and make it Ethernet to say, going to the vendors, you figure out how you're accessing this information. We're just providing the user interface through.
Right, right. So I think, so where I was going with this, and actually an important thing to keep in mind from the Zoom comment is, don't think of it as purely, and I think to Shannon's point, I would very strongly ask you to think about this not be seen as a NetDev or a network interface problem. Because, by the way, there are PHYs on PCI, there's PHYs on things that are coming with UVC, UA-Link, blah, 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 that are all going to have this exact same problem. And Ethernet is a bit of an interesting problem because there are famous things like NVLink, which is actually an Ethernet PHY on the bottom, right? So you should be able to see the Ethernet PHY stats the same way. There's no reason for it to be different. So where I was going with this is, one thing that you could possibly do is actually provide a framework. Like if we did something like what Windows did with WCL, network interface layout, if we actually as a Linux community said, we expect your hardware interfaces to look like this and propose what the minimum set needs to be, we can actually direct this, because to the point Mike was talking about, some of the problems here is hardware teams don't even know what standard to comply to. There isn't one, like you said in the beginning. So what maybe the most valuable thing that can come out of this is for there to be a proposed interface spec that says, don't worry about how the software will handle it, but hardware vendors, please provide your interface to look like this. Because if somebody had a map, it's easy to put it in. It's just that people don't have such a thing.
I mean, I will say, I think it's going to be a hard task to get all vendors to just go with the Linux way.
No, I'm not saying that. See, the way, if you see how Microsoft did this for the NIC world 20 years ago, they didn't do that. They said, here's a spec, our drivers will use this kind of interface directly. That's all you need to say. Because if I'm building a chip, I have to invent a register map, or I have to invent an interface map. If somebody told me, do this, I will use it. There is no reason for me to not use it. It's not like it's making me uncompetitive. It's just that today there isn't a thing that people can go look at. So if we were to go out and actually put it out there, I think you will see very wide adoption very quickly.
Yeah, I know some hardware engineers at Microsoft, so I'll pick their brains on that as well.
Yeah, I was just going to basically, I think you more or less said what I was going to say. So yeah, essentially, to some extent, we aren't trying to force vendors into, you have to implement this. It's not we're not expecting all legacy stuff. The general idea is try to come up with an interface that they can implement, so we're not blocking this, and we can try to coalesce towards one standard interface going forward. So.
Okay. Well, I will take all this feedback and start mailing to various lists, it seems. But thank you very much.
And you are absolutely on time. You made good time.
Thanks.